Okay, this next one, it's like number 7 on your homework, and it's really strange. It kind of goes against everything we just talked about. So just trust me, okay? We are still going to work on the left. That's not changed. The answer is still going to be on the right. That has not changed. Okay, but how we get there is a little different. Remember I told you anytime you see a squared, it should be an alert of a Pythagorean? Well, look, here's a squared. So alert, 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 alert. It's probably a Pythagorean. And I also see a plus sign. Alert, 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 alert. But what are we missing from a Pythagorean identity that has a cotan squared and a plus sign? Well, let's see here. Here's a Pythagorean with a cotan squared and a plus sign. I'm missing this 1 right here. So if I could somehow change this problem into having a number 1 plus cotangent squared, I could do something. I could make it smaller. So how can we somehow make this sign a 1? Well, it's easy. You factor out the GCF. What's the GCF of these two terms? Hello, sine. So let's factor it out. We get sine theta parentheses 1 plus cotangent. Yeah, because if I divide sine by sine, I get 1. If I divide this sucker by sine, you just get cotangent squared. Okay, and then alert, alert, alert. Anytime you see a squared, a 1, and a plus or minus sign, it's probably a Pythagorean. And it is here. 1 plus cotangent squared is equal to cosecant squared. So I'm going to replace this big nasty with cosecant squared theta. We're simplifying, making it smaller. It's just kind of awkward. Okay, now let's rewrite in terms of sines and cosines. So I know we kind of went a weird way about it, but it's okay. So the sine is good to go, but let's find something for cosecant squared. Cosecant squared. I want cosecant squared to be equal to something with a sine and a cosine. So let's look. Here's a cosecant squared, but it's equal to cotangent. Pooh! Here's a cosecant, and it's equal to 1 over sine. And remember, it doesn't matter. If I have cosecant squared theta, that's equal to 1 over sine squared theta. If I have cosecant to the 22 power theta, that's equal to 1 over sine to the 22 power theta. So anyway, this cosecant squared is going to go to 1 over sine squared theta. And then we are still going to have this sine out in front. I just changed the parentheses to a multiply dot. Okay, so what we did write in terms of sine and cosine, but we also did something even more special. We did a reciprocal identity. Yeah. Okay, now, I don't know if you remember this, but we can cancel the sine on top with 1 of the sines on bottom. And we get 1 over sine theta. And then that's another reciprocal identity. We just get cosecant theta because 1 over sine theta is cosecant. So that very last thing we did was we did a reciprocal again. And back over here when we canceled, I forgot to tell you, we divided out the common factor. Remember, that's what it's called when you cancel.